allotropy of carbon. An element in different forms having different physical properties but similar chemical properties is known as allotropy. Carbon has numerous allotropy and is classified as crystalline and amorphous. Crystalline are further classified as diamond, graphite and fullerenes. Amorphous is classified as coal, charcoal and lamp. Coal is the gas and petroleum products. Charcoal are further classified as wood charcoal, sugar charcoal and animal charcoal. In this module, we will just discuss the crystalline allotropy of carbon. Diamond. In a diamond, each carbon atom is joined to 4 other carbon atoms in a tetrahedral manner. 3 tetrahedral joined to form a puckered 6-member ring and capped by 4 tetrahedrals to form a large structure. Repetition of this structure to form a 3-dimensional structure is shown here. So, it is a covalent network solid, which are hardest substances. Graphite. In graphite, the carbon atoms are arranged in flat parallel layers as regular hexagons. Each carbon in these layers is bonded to 3 others by covalent bonds. Graphite thus acquires some double bond character. Each layer is bonded by adjacent layers by weak van der Waals forces. This allows each layer to slide over the other easily. Due to this type of structure, graphite is soft and slippery and can act as a lubricant. Fullerenes. Fullerenes form another class of carbon allotropes. The first one to be identified was C60, which has carbon atoms arranged in the shape of a football. It contains 5 rings membered and 6 ring membered of carbon atoms.